So today we would like to talk about the concept of urbanization effect, or you can call it the urban heat island effect. You can find it in your textbook page 29. So I hope that this video helps you understand more regarding the important key terms and also the concept about it. So the urban heat island effect, I would treat it like the same concept as microclimate that we learned in the tropical rainforest region. So what does that mean? For example, the annual mean temperature of Hong Kong that we learned, okay, is around 24.8, or can say 25 degrees Celsius. Okay, so it's called the annual mean temperature. So around 25 degrees Celsius. But then, this is the general temperature. But in the urban areas, we often observe a much higher temperature, okay, especially during the nighttime. So in this regard, so you can find a temperature of a certain place that is distinct from the overall temperature pattern of a place of Hong Kong. Then it's like a microclimate, just like the rainforest. So with areas covered by rainforest, so there's significant difference in terms of the climatic characteristics, like the temperature at the bottom may be lower, the wind speed may be lower, so on and so forth. So it's kind of like a microclimate condition. So let's have a look at this example. So we have Tsim Sha Tsui over here, which is the urban areas, and then we have the northern district, Da Gu Lan, over here. So you can observe that there is a significant difference of 2 to 3 degrees Celsius, okay, regarding the air temperature. And then one more thing, which is more interesting, is that if you look at this diagram, this figure, you can see that the temperature difference is more significant during the nighttime. Okay, in the daytime it may be 2 to 3 degrees, okay, Celsius different, but then during nighttime it can reach more than 10, okay, or even larger difference. So this concept, okay, is actually linked to how heat is being dispersed in the urban and rural areas, and also where are the heat sources. So today we would like to go through it very quickly. So there are a few reasons behind. So there's a landscape over here. The one over here refers to the urban landscape, A, and then we have the rural areas over here. So one of the very, very important concepts that we also learned when we talk about the tropical rainforest is about the property of trees, right? So in the urban areas, we rarely have trees, or I mean there are trees, but of a much lower density. But in the rural areas, we have quite a lot of trees. Okay, we have what we call the green belts in the textbook, or you can simply call them the green areas. So trees have a very important, okay, actually there are a few important functions. One of it is called transpiration. So, and then in the rural areas, suppose we also have more water bodies that are direct to the sunlight. Whereas in the urban areas, some of the rivers or the streams, they may be actually being covered by the concrete surface, just like the one next to QC, right? So as a result, for water body, evaporation will occur and is faced with direct sunlight. So what happens is that transpiration, evapotranspiration combined together. So when they occurred, they are going to take away some of the heat energy, okay, to convert the water into water vapor. So this is actually going to lead to what we call evaporative cooling effect. So there will be more cooling, okay, in the rural areas because there will be more evapotranspiration. So less heat is, okay, retained in the rural area. But in the urban areas, this is not happening, right? So this is the reason number one. We have more trees, so there will be more evaporative cooling. Reason number two, so it's about the density, okay, of the urban landscape. So over here, we actually have very tall and, of course, and dense buildings in the urban areas. So as a result, it's quite obvious. Whenever there is wind blowing through, okay, passing through the urban areas, so basically it's going to be block by those buildings. As a result, wind speed in the urban areas will be much slower. As a result, less heat can actually be dispersed or being carried away, so causing more heat to actually accumulate in the urban areas. So, and then let's move on to another reason. The third one is actually related to the building materials. So there are two thermal images over here. Actually one. So on the right hand side will be the landscape. So you can see that on the left hand side is actually buildings made by what we call concrete. And then on the other hand, right hand side is a tree. So what's the difference between the two is that most urban materials, okay, compared to trees, so concrete, or you can say urban materials, will actually have what we call a higher heat absorbing capacity. So they can basically absorb, okay, and retain more heat. Whereas for trees, so it's much lower. So what does that mean? So that will help explain what happens at the night time. So at night time, so there's no sunlight, so heat started to escape the area. But since in the daytime, the urban areas, the concrete, they traps and absorbs a much higher amount of heat, so they will emit the heat slowly, okay? So causing the nighttime temperature to be higher. So let's move on over here. There's one more thing that you may want to know is about the modern urban areas. So some of them, okay, the buildings, they're actually covered by glass cover, right? The layer of glass, like the office buildings. So, and then in the urban areas, we have a lot of these. But then you can see that these type of glass, they will actually reflect the heat source like this. So when the sunlight starts over here, so only the light can pass through, go into the building. So let me draw it out like this. So we have a buildings like this, covered by glass. And then when the solar radiation arrives, only the light goes in. But then the heat will then be reflected. So where will they be reflected to? Most likely, they will be reflected to the building next by. And then the light or the heat will then be kind of, okay, reflecting, and then they are trapped, so they can't escape. So causing the urban areas to be much hotter. So lastly, there's one more, but this one is actually quite easy, so I'm not going to talk too much about it. So it's about the last reason. We call it the man-made heat source. So we actually have a lot of heat source, like vehicles, okay, like air conditioners, ventilation system, okay, engines, so on and so forth, that can only be found in the urban areas. So these type of, okay, engines, machines, they will create heat, and then the heat as a result is being accumulated more and more in the urban areas. So that's all regarding what you have to remember for your upcoming exam. So I hope that it helps you understand the key terms more easily.